Hi, this video is about periodic trends. You've just finished a project where you investigated the periodic trends of atomic size, ionization energy, and electronegativity. And this video is going to explain those trends that you've discovered. First of all, let's look at the periodic trend of atomic size, sometimes called the atomic radius. So, within a group or a family, so those vertical columns on the periodic table, the atomic radius will increase when you go from top to bottom. So when you go down this family, what's happening is you are adding shells or energy levels of electrons. And so as you go down, the size of the atom is also going to increase. But how about when you go across a period, when you're going left to right? So when you go across, the atomic size actually decreases, which can seem a little confusing because when you go left to right, you're adding protons and electrons into the atom. However, the protons are being added in the nucleus, but no additional energy level is added for the electrons. So as you go from left to right, the positive charge in the nucleus increases, so it pulls in those electrons tighter because there are more protons in the nucleus. So to summarize, I think a picture is a great thing. As we see here, as we go down, the atomic size increases. And as we go across, the size decreases. So you need to know this trend. So let's go ahead and practice. We would like to list the following atoms in order of increasing size. So increasing size means we want to go from smallest to largest. Okay, we're looking at oxygen, sulfur, and fluorine. Who is the smallest? Oxygen, sulfur, or fluorine? Well, fluorine will be the smallest because it's to the right, so it's farthest to the right and highest up. So fluorine is the smallest, and then oxygen, and then the largest is sulfur because it's, down below. Okay, let's look at sodium, beryllium, and magnesium. So we have sodium, beryllium, and magnesium. The smallest is going to be beryllium, followed by magnesium, and the largest will be sodium. These are the types of questions that you're going to be asked on some type of test or quiz about periodic trends. All right, ionization energy. It really measures how strongly an atom is holding on to its electrons. So the definition is the amount of energy required to remove electrons. So if an atom is holding tightly onto some electrons, then the ionization energy would be high. So, things that affect the ionization energy are the charge on that nucleus and how far the electron is from the nucleus. So the trend for ionization energy is that as you go down the periodic table, the ionization energy decreases. And so why is that? That's because these electrons are now farther from the nucleus when you go down the periodic table. So it's just the opposite of size. The atomic size is increasing, but the ionization energy is decreasing as you go down from top to bottom on the periodic table. And as you go across a period, remember the size was decreasing, and so those electrons are being more tightly held by that positive nucleus, so the ionization energy will increase as we go left to right. Okay, so select from the following list the atom that has the greatest first ionization energy or the highest first ionization energy. So we're looking for the one that has the highest ionization energy, the one that's going to hold on to its electrons tighter than any others. So we have sulfur, chlorine, selenium, and bromine. And let's go ahead and look at a periodic table. Between chlorine and bromine, chlorine has the higher ionization energy. Its electrons are held a little more tightly. And then our other choices were between chlorine, selenium, and sulfur. So chlorine and selenium, again, chlorine would have the higher ionization energy. And between sulfur and chlorine, again, chlorine would have the highest ionization energy. Okay, so let's go to the second question here, letter B. From this list, we want the lowest ionization energy, the one that will give up its electrons the easiest. Boron, aluminum, carbon, and silicon. So boron or aluminum would have the lower ionization energy. Silicon, aluminum would still be lower than silicon. And what was our other choice? Carbon. So aluminum versus carbon, aluminum again would have the lowest ionization energy of those choices. Okay, so ionization energy, left to right, it increases, top to bottom decreases. Just the opposite of the trend for atomic size. The last trend we're looking at is electronegativity. It's the ability of an atom to attract electrons to itself. And you can assign numbers for electronegativity, and they range from something like 0.7 all the way up to 4. Now, if you can remember that fluorine has the highest electronegativity, in other words, fluorine really, really, really wants electrons. And so that makes sense because of where it is on the periodic table. It's one away from a noble gas, and it's, this electron shell is close to that positive nucleus. So if you say ionization energy increases from left to right and it decreases from top to bottom, or it increases from bottom to top, just remember you're aiming for fluorine. If you can remember that fluorine is the most electronegative atom, then you're good. The top 4 electronegative atoms on the periodic table are fluorine, oxygen, nitrogen, and chlorine, and that spells Funkel. So those are the highest electronegativity atoms on the periodic table. Let's just quickly look at cations and anions and how big they are compared to the atom that they came from, called their parent ion, their parent atom. Here's sodium. When it loses an electron, it becomes sodium plus 1. And so the cations are always going to be larger. The cations are always going to be smaller than their parent, and that's because they have lost an entire valence shell. So cations are smaller than their parent. I like to remember cats are kind of small, at least in my house compared to my big dog. And anions are when you've gained electrons, and when you gain an electron, it increases in size. So anions are always larger than their parent atom. And again, cations are smaller because they've lost a valence shell. Anions are larger because you've added now yet another negative electron, and like charges repel one another, so the anion is larger because of electron repulsion. Okay, so you need to know those trends. The reason behind the trends hopefully will help you remember them, but please know these periodic trends and the definitions. Have a good night.